Circle has this equation, and then a regular hexagon is drawn inside, so the vertices touch the circle. What's the area of the hexagon? Okay, we'll get to the hexagon in a minute. Let's get the equation of the circle down by completing the square. I'm going to get x minus 9 squared minus 81. Sorry, I was going to do that at the end, but yeah, let me write it here. Minus 81 plus y minus 11 squared minus 121 plus 178 is equal to 0. So that means x minus 9 squared plus y minus 11 squared is going to equal, let me add these two, they're both negatives, so I'll get minus 202. So when I put it on the right hand side, I'll get 202 minus 178, which will give me 24, or root 24 squared. So the radius is root 24. Okay, I'm going to draw a little sketch. So the center is going to be 9, 11. I'll just draw this first quadrant therefore, because it'll fit in it nicely here. 9, 11. All right, let's put it here. And then the radius is less than 5. So not that it really matters, but I'm not going to intersect in the axes. I'll just sketch it like that. The main purpose now is to see that I can draw a regular hexagon inside it. It touches the corners, so something like this. And we're asked to find the area. Okay, now a regular hexagon, let's work out you might know the interior angles, you might not. It depends how much you do sort of math challenges and stuff, where this always comes up. Quickest way to find the interior angle of a regular hexagon is to first of all find the exterior angle. Exterior angles always add up to 360, so 360 over 6, we get 60, and then do 180 minus that, so 120 for the exterior angles. You could also do the number of sides minus 2, 4 times 180 divided by 6. 4 times 30 is 120. Now what follows is a little fact. It's worth knowing this. You can split the hexagon like this. It goes through the center. It must do. If I basically bisect each of my angles, I'll get to the other side. And what I've actually created are 6 equilateral triangles. This is a little fact, and actually it's how you can make a really nice regular hexagon using just ruler, compass, and pencil. You can use this idea of equilateral triangles. I'm not going to go into it here, but yeah, basically this is what you get. So to find the area of the hexagon, we find the area of one of the triangles and times by 6. And they're equilateral, and we know the radius. So we know each one is root 24. And we know the angle is going to be 60 here, because it's 360 divided by 6, and you can also see it's 60 here, 60 here, and these are the same, however you want to do it. So there's 2 ways you can do it now. The quickest way is to use a half AB sine C. So it'll be a half times root 24 squared times sine 60. This is just for one triangle, remember? So that will be half of 24, which is 12. Sine 60 is root 3 over 2. So we're going to get 6 root 3. And therefore, for the area of the hexagon, it's going to be 6 times 6 root 3, which is going to give me 36 root 3. The complicated route that doesn't require knowledge of non-right angle trig is to use Pythagoras' theorem. So I will go through it like that. It's just more awkward because it's a third. But I can divide the triangle into 2 parts. And then this here will be root 24 over 2. And then to get the height, or the height squared, it's going to be root 24 squared minus root 24 over 2 all squared. That'll become 24 over 4, actually. And I'm going to get 18. So h is root 18. And then the area will be a half base times height. I've now worked out the height. So half times root 24 times root 18. Okay, probably best to simplify each of the thirds. So I could write this one as 4 times 6, so 2 root 6 times, well, root 18 is going to be 3 root 2. So I get the half and that cancelling, I get 3 root 12. Might be better ways to do this. But that then itself becomes 2 root 3. So I'll get 6 root 3 that way as well, and then times 3 by 6 to give the answer.